Hey everybody, okay, so now we're going to add and subtract rational expressions, but these have a common denominator, which makes our life just a little bit easier. Okay, so this page is just a reminder that you need to have a common denominator to add your numerators together, okay? And whenever you add, you don't add your denominator. Your denominator just stays that number, okay? So, in other words, if you have 1/4 of a pizza and you eat another 1/4 of a pizza, you add your numerators, but don't add your denominators, okay? And so then you end up, if we reduce this, we end up with 1/2. So we have half of a pizza at that point, okay? So, just so you know, do not add those denominators together, okay? Only add your numerators. All right, just a reminder of how to do this. So we do have a common denominator, 18 and 18. Those match. That's good. So by the way, I've said it before. I'm going to say it again. This number right here, or this dot right here, is just the end of a sentence. It's a period, okay? So it has nothing to do with the mathematics of this problem. It is not a decimal. It is just add these things, period. Okay, so I wish they would stop putting the periods in there because it can be confusing, but again, I didn't write the book. So, all right, so let's add our numerators together. We get 5 plus 7, which is 12. We do not add our denominators together. And you guys, if you haven't heard this before, you are hearing it now. I always want the most reduced form of a fraction that you can give me, okay? So if you give me 12/18 on a test, I likely will take off points for that because you should be giving me the reduced form, okay? And they're both divisible by 6, so I would end up with 2/3 as the reduced form of this fraction. All right, so let's take a look at this one. Do we have a common denominator? Yes, we do. So we are allowed to add the numerators together, but they don't have any like terms. That's okay. We just write them like this. Remember, do not add your denominators. Now, if we could factor either the numerator or the denominator or both, then we would, and we'd see if we could mark out some of the same factors, but we can't. This is not factorable. There's not a GCF there. This is not factorable, and they don't have a GCF either, other than one. So really, this is as good as this gets. All right, again, we do have a common denominator, so that means we're allowed to add any like terms together. If we don't have any like terms, we just write them out. Okay, and we don't have any like terms, so I'm going to write them in standard form, starting with the x squared term. And then what I have in the denominator is x plus 3. Now again, last time I told you if you can factor, you should, because you might be able to mark out some like factors. And in this case, we can factor it, so let's go ahead and factor it, okay? So we would get x plus 3 and x plus 4, and look at that. We can actually mark out the x plus 3's because those are the same factors, right? And so what are we left with? Well, we are simply left with x plus 4 as our final answer. This page is just a reminder that you do the exact same process for subtraction as you do for addition. The only thing is I want you to think just a little bit harder about this. Maybe set off an alarm in your brain that whenever you subtract, don't forget to distribute this minus sign to every term immediately following the subtraction sign, okay? And I'll show you what I mean by that here in just a second. But I want you to set that alarm in your head going, oh, I've got to do something extra, okay? It doesn't happen all the time, but if there's more than one term following, then yeah, you do need to distribute that minus sign, okay? And again, we'll talk about it here in just a second. But also, do not subtract your denominators. Otherwise, you'll end up with 0 in the denominator. You don't want that. All right, so take a look at this. Do we have a common denominator? And I keep on saying that, and I know that you guys are rolling your eyes at me. I can hear you. Anyways, yes, and this whole time I'm going to keep on saying it because I want that to be the first thing that you think in your head is, do we have a common denominator in the next video, okay? So in today's video, yes, we're going to always have a common denominator. All right, so right here, we have a common denominator, so we are allowed to go ahead and subtract our numerators. They're not like terms, so I can just write them like that. Am I finished? Nope, I'm not done. Remember that numerator can be reduced, right? Where'd that line come from? It can be, or it can be factored. So let's factor it. N minus 10 and n plus 10 over n minus 10. Now, we do have some like factors to mark out. Those guys are gone. All right, what are we left with? We're left with n plus 10. And we're done. Okay, take a look at this one. Do we have a common denominator? See, now I can really hear your eyes rolling. All right, yes, we do. Okay, so let's go ahead, and this is what I was talking about. Do you remember whenever I said be extra, extra careful? When you have a minus sign, you have to distribute the minus to each term following, okay? So what that means, let me erase this, make it all clean and pretty, is we're going to do change, 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 okay? So whatever the sign was, it changes, okay? All right, only do it to the numerator. Don't worry about doing that to the denominator, all right? So what we have now in our numerator, because we have a common denominator, is we have y squared minus 2y minus 24 over y minus 6, okay? So now, can we factor this numerator? You know what? Here's something you need to think about. Wouldn't it be nice if this was one of the factors in the numerator? So maybe that should be one of the things that you start with. If you had y minus 6 as one of the factors, what would be the other factor? So think about that. Well, I think if we have y minus 6 as one of the factors, the other factor would have to be y plus 4. Does that work? Do they multiply to be negative 24 but add up to be negative 2? Yeah, they do. All right, so then I've got y minus 6 in the denominator, and we can mark those babies out. And what are we left with? We are left with y plus 4. That's it. Holy moly, this just got real, huh? Look at that. It looks like a hot mess, doesn't it? All right, let's distribute that minus sign though, okay? So this becomes a plus, this becomes a minus, this becomes a minus, and this becomes a plus. Do you see that there? Okay, all I did was I changed the sign of every term in the numerator immediately following the minus sign, okay? Now, we do have a common denominator. I'm still saying it. And that means that we can combine our like terms in the numerator, okay? So our like terms right here, 5x squared plus a negative 4x squared, just gives us plain old x squared. Then we have minus 7x plus a minus x. That gives us a minus 8x. Then we have a plus 3 plus 9. So that gives us a plus 12. All over x squared minus 3x minus 18. Now, I believe the numerator and the denominator are both factorable. So let's factor those babies real quick. So the numerator, we want it to multiply to be 12, but add up to be negative 8. I think that is probably x minus 6 and x minus 2. The denominator, we want it to multiply to be negative 18, but add up to be negative 3. That is x minus 6, x plus 3. Now let's mark out our like factors. And so what are we left with? We are left with x minus 2 over x plus 3. And that's it. That's all we can do. Remember, you cannot mark out those x's. Why not? Because that x is married to that minus 2, and that x is married to that plus 3. Okay, I kind of lied to you. I said that in this video, they would always be the same denominator. Well, this one isn't quite, right? So check this out. They're close though, they're opposites of each other. So let's move this thing around. What I mean by that is I can write it like this. Well, do those match now? No, they're still opposites of each other. But what if I multiplied by -1? What if I also multiplied the numerator by -1? What is -1 over -1? It's +1, isn't it? You are allowed to multiply by a version of 1 to make your fraction look the way you need it to look, okay? And we're going to get more into that in the next section, but -1 divided by -1 is +1, so we've actually multiplied by 1, okay? So now we have 4u minus 1 over 3u minus 1 plus -u over, and look, if I distribute this, right there and there, I get 3u minus 1. Now they match. All right, so now let's combine our like terms. Our like terms are here and here, and that's it, okay? So we end up with, what is 4u plus a -u? That's a 3u. Don't forget your -1 over 3u minus 1. Hey, what happens whenever something is divided by itself? That creates 1, doesn't it? So our answer is 1. Again, that offends me. I did all this work just to get an answer of 1. You know I'm kidding, right? All right, last example. And look, they did it to us again. The denominators don't match. All right, so let's doctor up the one on the right real quick. So I've got -m squared plus 1, but that still doesn't match. So if I multiplied by -1, would that give me what I have over here? -1 times -m squared gives me +m squared. -1 times +1 gives me a -1. So yeah, that works. But remember, what you do to the denominator, you have to do the identical thing to the numerator. So the numerator, I've also got to multiply by -1. Okay, I'm just rewriting the first fraction. Now the second one, I'm going to go ahead and distribute the -1s through. Okay, now I'm going to get rid of this minus sign in the middle. So negative, and then change the sign of every term after that. Okay? Now I can combine my like terms, and I end up with m squared. Now, the like term here is -6m plus a +3m, which gives me a -3m. And then I've got plus 2 all over m squared minus 1. Now, let's try to factor. So the numerator factors to be m minus 2, m minus 1. The denominator, this is a difference of squares. A lot of people have a tough time realizing that 1 is a perfect square, but it totally is. Okay, so that's that conjugate pair. Now let's mark out our like factors. There and there. Gone. All right, so what am I left with? My numerator has an m minus 2. My denominator has an m plus 1, and that is it. Bam. All right, you guys. You know I'm here for you. You know that all you have to do is reach out, and I'll be happy to help you. Let me know if you need anything, and you have a wonderful day.